Hey everybody, welcome back to the channel. So today's video, I've got something a little bit different, project that I'm working on that I'm really excited about. And I know my face doesn't always show excitement very well, but trust me, I'm extremely excited about this. And I say it's a little bit different, but it does tie in a couple things that I've shown on the channel before. One being the Starlink Mini dish, and the other being my 3D printer. So a few months ago, I bought a Starlink Mini, which if you're not familiar with it, it's a small, about notebook paper sized little satellite dish that will essentially give you high-speed internet anywhere that you can get a clear view of the sky. And it doesn't even have to be that clear of a view, as long as you can see the sky and you're in your service area, which for the Starlink Mini where I live, it covers anywhere in the United States plus like 8 miles offshore. So a really versatile piece of equipment. But something I came across when I was looking up things to 3D print was a design that somebody came up with to make it even more portable. And that's what I'm going to go into today. This will be the first time I've really soldered anything electronics wise. So I'll be learning right along with showing you guys. I'm going to show all the parts that were needed for it, show the design itself, and hopefully take you along with me as I do each part to show you how it goes together. So hope you enjoy the video. All right guys, so the first thing I want to do is give the designer of this project credit, because I did not design this 3D printable design, nor come up with any of the parts that came with it. So the way a lot of 3D printing models work is a lot of them are open source. So they're posted online, whether it's through Bambu's app or Thingiverse, or there's a lot of different sites that have 3D printable models. And it's really neat because they're shared among everybody. So there's literally millions of designs out there that you can go pick from. So this one, if you'll take a look over to this side of the screen, I'm going to show on my phone. If you go to the Bambu app, I've already got the design pulled up here. So this design, it doesn't have the person's actual name. It's got their account name, which is DIG, D-I-G-G. This is just a really cool thing. So it's got a picture you can see up at the top of the Starlink Mini with a DeWalt battery connected to it. So I haven't really described yet fully what this is. So essentially this project is a 3D printable casing with a circuit board and some other wiring to be able to connect a DeWalt 20-volt battery directly to your Starlink dish, which will allow you to have even more freedom than you normally do. The Starlink is extremely versatile with what power it can accept. So it's got a pretty wide range of AC and DC that you can power it with. And so what this adapter allows you to do is just connect your standard 20-volt DeWalt drill battery to it, and all of a sudden you have high-speed internet no matter where you are. So on this design, he's got it to where you can immediately go in here and print 2 plates worth. And you can see I've already printed both of these. They're showing up in red. I did it in blue just because that's the material that I had. I did use the PETG, which it recommends, which if you're familiar at all with 3D printing, you got several different filaments you can use. PLA is the most common. It's cheaper, but it's also a little more brittle and it's not as heat tolerant. So PETG, it's slightly flexible, so it's a little bit more durable, and it stands up to heat better as well. So I chose to go with that, and blue was the only color I had in PETG. So basically you pull this up in the app, you can print each one of these designs, and as you can see, if I go to this 3D preview, you can see that first piece on the print plate, and you know, if I were to change it to blue, for example, that's what it would look like. And you can see this piece is what I printed out based on that design. So it's really cool how you can just pull up this design, send it to your printer, and have a basically custom-made part printed out. So going back to the main page here, this creator, Dig, has put together very good instructions on exactly what you need. So if you can see this bill of materials, and he's even got Amazon links listed for each of the things. There are a couple of them that didn't have direct links, but I was able to look them up on Amazon. I bought all the pieces on Amazon, and I'll go through and show some of those as we go. But essentially, you've got your main body piece. You've got these little circuit boards, which are pre-made and purchased through Amazon. The circuit board will be mounted in the middle. It's got some these little tabbed connectors that will serve as the battery contacts for the DeWalt battery once you get it in place. It's got these little, I don't know what you call them, barrel type DC connectors, also ordered directly off of Amazon. And then kind of shows you exactly how to put it together with little descriptions as well as pictures. So it's just really neat how they've got these designs licensed. And as you can see, the license allows you to distribute, remix, adapt, and build upon any of the materials, as long as you give credit to the creator, which is what I'm doing now. And it's non-commercial use, so I can't just produce these and sell them, for example. So I am making this for myself. But anyway, it's just really neat. I appreciate him for putting this together. Certainly probably took a long time to come up with this design, to actually do the 3D modeling. If you've ever done any of that, it's pretty time intensive unless you really know what you're doing. And so, it saves hours of just design work, being able to send this to the printer. So really appreciate him doing that. And I'm excited about walking you guys through the process. Again, learning as I go. I've never done any electronic soldering. I've done some very basic soldering of wires to connectors, but nothing on like a circuit board. So I'll be learning as we go as well. I hope this is informative. I guess we'll get right into it. So while the soldering iron's warming up, I just wanted to show some of the main components here. So you got your 3 basic 3D printed body components. You've got your brass screw inserts, which, they came in like a pack of 100. You can see how these are set up. They've got little ridges on the sides that help lock it into the plastic once it melts in there. Kind of neat. I didn't know anything about these until I started looking at 3D printing stuff. Then you've got your switch components, just a basic rocker switch with the wires that go along with it. These 2 little blue paddle connectors that will serve as the contacts for the DeWalt battery. You've got your little circuit board here, and that came pre-assembled from Amazon. The instructions do have you remove these 2 green connector posts, and we'll solder directly to the board. That just saves some room inside the casing. And then you've got your connections that will go, this will plug into the actual Starlink terminal. And I don't think we even need the female end of that one, but those obviously came as a pair. This soldering iron I actually bought off of Amazon. It was super cheap, I think it was like $9, really cheap. But I wanted it to have the adjustable temperature. Part of that's because these little brass inserts, you don't want to over melt this material. It can just cause them to be misaligned and can mess up your print. So they recommend getting an adjustable temperature soldering iron. Obviously there are better ones out there, and really a lower temp would be even better. I think somebody online said that around 200 degrees was preferable, because that gives you just kind of a nice, easy, soft melt without getting it too melty. So I have to be really careful with this. But 356 is the lowest this one goes, so I've got it turned all the way down, and I think it's already up to temperature. You might have noticed this shell casing over here from a Spent 270 cartridge. And what I'm going to use that for is once I press the brass fitting into here, somebody online also mentioned that it's good to, in order to get them flush and even, what they did was took like a hex head bolt and filed the end of it smooth so that they could then press, you get it almost flush, then you take your soldering iron off and you take something like this and press it flush. And what that does, that cold metal takes some of the temperature out of that material, so it helps it set, and it also just helps make it flush with the hole. And so instead of modifying a bolt, I had a shell casing sitting around, so that's what I'm gonna use that for. But anyway, we will get started now. I'm gonna mount my phone up on this mount so that I can try to give you a good view of this as I try it. And this is going to be no trial run, first test, very first time I've ever tried this before, so I'm a little scared, but I guess worst case scenario I just have to reprint a piece if I really mess it up. But anyway, here goes nothing. So we'll take our little piece here, set it right over the top of this hole. Doesn't have to be perfect, so I'm going to line it up with the soldering iron. So I'm going to take my soldering iron, stick it right in the top of it, and then line it up just just like that. You can see it starting to sink in as we speak. And leave it sticking out just a hair. I think that did pretty well. Seemed pretty easy. I'll probably get the next one just a little further in before I try to set it, because it sets quicker than I thought once you get it started. And it doesn't take long for that heat to get it moving. And as you can see, it just kind of slowly sinks right in there. You just pull that out, set it flush against the material. Y'all can see, if I get that kind of close, it makes it a really professional look. It just sits right in there flush. Got all 4 of those brass inserts in. They actually went a lot easier and smoother than I thought they would. And then these are the other 4 that are in place as well. So that part's done. Next, we're gonna move on to desoldering these 2 little green posts that are normally made for your power in, power out. And we're going to desolder those from the back. And again, this will be the first time I've ever tried this, so wish me luck. Looks like it kind of worked. If you can tell the difference in that. It did kind of suck the solder joint off of it. We'll see if it's still loose enough to actually pop out of there. Do the one next to it now. Those of you who really know what you're doing on this, probably shaking your heads right now, because I really don't know what I'm doing. I don't know if you can see this. I've got pretty much all the solder removed from around the post, but it's still just enough to make it stick in there. Welcome any comments down below if you have a secret to how to do this. Alright, so I've got the 2 green connector pieces removed. I had to get my son in here to help hold the side of this board so I could have a hand freed up to grab onto the green thing with the pliers while I heated the connection. But as you can see, the V in and V out spaces on the board are now open, so we can solder our new wires on when we get to that point. The next step is going to be to attach our newly modified board onto our frame with 4 M4 screws. It's going to mount right there. And that's one thing I forgot to mention when I was looking at my parts, is it only takes a few screws, but I couldn't find them by themselves. This pack was very inexpensive, and it has like 5 or 6, maybe 8 different sizes of M3 screws, different lengths. It also came with the nuts, which we're not going to need. But anyway, yeah, next step's going to be attaching the board, and these don't actually thread into the brass fittings. These go directly into the board. They're sized for that. All right, next thing, I'm going to attach our circuit board to these 4 screw points right here, using 4 of the 4mm long M3 screws, and they're going to go straight into the printing. I'm going to make sure I don't over torque those. But the way this printing is made, it really is pretty neat because it's got everything just exactly in the right spot. One thing I'm gonna have to be careful with when I resolder these connections on is not heating this board up excessively, because this plastic will begin to melt around these screws if I get it too hot. So it's just something I'm gonna have to keep in mind. And again, since I'm very not proficient at this, so I think that should be good. As you can see, those are 4M screws straight into the printing. All right, and I've gone ahead and removed the blue plastic part off of one of these connectors. I'm gonna do the same thing to this one, and this is gonna be the part that goes in these little slots right here and right here. These tabs will be what the DeWalt battery makes contact with. So I'm gonna start wiring up the rest of this stuff. This is probably gonna take me a while. I'm gonna have to take my time and make sure I don't mess this up. But I will try to film what I can. My hands are gonna be right up here in the way, but I may put something up on the screen to show you the kind of the diagram that the creator of this put together. And it's a really good picture of what needs to be done. But I'll have to show that up there in a minute so you can actually see, because my hands are gonna be in the way. One thing I've learned through this is that I am horrible at soldering, and I guess that's to be expected for my first try, but you know, feel free to make snide comments about the soldering joints. I just hope they don't short out, because I've got so much stuff piled up on there after doing my best to get those to stick. Trust me, I know I'm not supposed to use that much solder. I just am awful at it, so that was the best I could get. So we'll see how it goes, but as you can see, just from the general layout, you've got your battery terminal inputs. Your black goes to your black in, and then your red goes over to your switch, which then comes back over to your power in on the positive side. And then it's going to go through the circuit board, and your two outs, red and black, come to your male barrel connector over here. That's going to go into the Starlink. So I'm going to go ahead and put this cover on and put the screws in, tuck all the wires away, and hopefully it's soldered well enough and not over soldered enough to actually work. We'll see in just a minute. All right, so I've gotten the covers put back on. I did have a little bit of trouble at first getting this right prong to come out far enough because of the way the solder joint was behind it. You can see it's pretty much even. It's slightly shorter than the other prong, but when I first connected the battery, it wasn't coming on, and I had to pull that back off, clean out some of that solder on the outside, and pull that out further. But now that that's together, you can see kind of what the whole unit looks like. The only thing I have left to do is to glue the two little clips in these holes, and that's just part of what snaps it into the Starlink dish that makes it hang on to the dish. But I'll demonstrate real quickly. This is one of my DeWalt 20-volt batteries. You can just slide it in here just like you would onto one of your tools. So it just snaps in just like that. And you get your on-off switch. Pop that on. You can see your digital display. It's reading 16.3 volts right now. It's a little bit hard to see because of the glare. But there are two little buttons that you can raise and lower. They're right inside those little slots that are cut out, and you can use a little Allen key or something to reach in there and push the little buttons on the board, which is kind of neat. They even thought that through on this 3D model. But the person that made this said they recommended setting that at 16.5 volts cutoff voltage. So that's what I've got it set to. It's giving us 16.3 right now. And so, yep, I'm gonna do a test with it later. I've got to glue these clips in and let that set probably overnight just to be sure it's set good. And anyway, that's it. So hope you enjoyed the video. I enjoyed putting it together. I will say the soldering part was kind of frustrating because I stink at it, quite frankly, and it took me a very long time, a lot of frustration trying to get those things to stick, but I learned something, and hopefully I'll be better at it in the future. And yeah, that's about it. I'll follow up with some testing on this and show you how it works. All right, for the final part of this assembly, I'm going to be connecting these little tiny clips into these holes on the back of the assembly here. And what I'm going to do that with is JB Weld, and this is the clear weld. If you've never used this stuff, I love it. It is really easy to use. It's a 1-to-1 mix, so it's simple to just, pretty much eyeball it. And what I like to do, I've got these little bitty teeny tiny, looks like my hand's huge. This is not a full-size cup, obviously. These are like little shot glass sized Dixie cups, and they're perfect for mixing up this stuff because you can kind of see. You just squirt them in there at the same time, eyeball, putting the same amount of each one in there. And I usually just use a popsicle stick to stir it with, but you just mix equal quantities. And right now I'm just going to squirt an even amount of each one of these in this cup. I'm not going to need a whole lot at all, just enough to get in there to where I can mix them evenly. I'll have about a minute to mix, so you just want to stir it for a minute, and then after that you've got about 2 more minutes before it starts setting up, and maybe 30 seconds to work with it after that before it's going to be too clumpy to actually work with. So you just want to stir this, like I said, for about a minute, and then you got another good minute after that. And sometimes it's good to wait that other minute just because you don't want it to be super runny. It'll start getting a little bit thicker, and when it starts getting that way, you better do something with it, because within a matter of about 30 seconds after that, it's going to solidify on you. And it does put out a lot of heat, so be careful what you sit it on. It's an exothermic reaction, and it gets really hot on the bottom of this cup. Today is the day after I assembled the Starlink Mini DeWalt battery adapter, and I'm getting ready to test it for the first time. So as you can see, I've got my Starlink Mini dish, just the dish itself, no cord or anything. I'm not even plugged into it yet. I've just got the adapter with it on it and hooked my DeWalt battery up to it, just a small one for this test. And this is the very first time that I will have even checked to see if this works. So you're seeing it with me for the first time. I have not done a test yet outside of this. So what I'm going to do is go out into my yard, and I'll pull up my app too and see kind of how it's doing, make sure it's working, make sure it connects, and hopefully it'll work. Let's check it out. And also, just a quick thing too, the overall size of this DeWalt battery adapter is so small that it easily fits down in the bottom recess of my hard case I have my Starlink in. And even if I throw a DeWalt battery in there, it's compact enough where they can sit down in this little cavity where the cord normally goes. I'm going to pick somewhat of a shady spot because it is pretty hot out here right now. I'm still in church clothes and it's very warm. So I'm just going to pick a spot in the yard right here, try to get where you can kind of see what I'm doing. So first I'm just going to take it, line it up with the power slot there, and just push it into place. So as you can see, it just slides right in there. Before I turn it on and check it, I'm going to pull up the Starlink app. So as soon as you open it, it's going to try to connect, and it's going to find that there's nothing there because I don't have this powered on yet. So you can see on the screen it shows Starlink disconnected, Starlink unreachable. So now I'm going to flip our power switch on, so you can see we've got about 15, a little over 15 volts. That is counting down. We'll see where that stabilizes. Power's fluctuating just a little bit. So maybe it's stabilizing now around 14 volts. So let's just set that down there. So far, it's not acting like it's powered up. I'm only getting 13.8 volts. Makes me wonder if this battery pack is too low. All right, so I've gone and gotten one of my other batteries that's fully charged. The first one I was testing with was the really small pack that doesn't have the battery indicator, and I'd been testing for it a while yesterday when I was doing the initial plug-ins to see if it would turn on. This one has got full charge, got 3 lights on it, and so now I'm gonna power this one on. Let me pull the app back up again, and I want to watch it real time. Turn screen recording back on. All right, so we are back in the Starlink app, and let's see if I can hold this where you can see it, because when I don't know if you can read that or not in the sun, but when I turn it on now, it's holding at 20.7 volts, which it was only showing like 13 volts on the other battery. So it looked like the other one was just about discharged. So this one's holding right at 20.6 volts. And again, in the sun you probably can't see, but the power on light, the blue light, is pulsing, which is a good sign. That shows that it's got power and it's starting up. So I'm going to set it down on the ground there. And go here in the app, and it's searching now. All right, now it looks like it connected, because it went from disconnected and searching to showing Cyberlink, which is the name of my Starlink dish. Optimizing connection. So at this point in the process, it's pretty neat. If you've got it mounted to the vehicle, you can't really do anything about it. But when you're just mounting it in the yard or in a field or in the mountains or wherever you are, you just set it down, and it will actually show you on the app, after it orients itself to the satellites, it'll give you pointers on which way to move it to get the best connection. So it's determining alignment. It says adjustment may be necessary in a moment. So it's getting its signal, and it'll actually show you on screen how to move it in order to get the best signal. So it's talking to satellites, determine which way it's pointing. All right, Starlink connected. May take a few minutes for connection to stabilize. All right, so apparently the way I had it pointing is pretty good. You can go to alignment, rotate, turn Starlink to match target. So it basically tells you can rotate it tilt is incorrect. Oh, Starlink is aligned. So it didn't take much adjustment, but you can see on the screen where it's now lit up around it, basically saying that's the best orientation. And we are online. So that is pretty cool. Let's see. We will run a quick speed test, just see what it looks like. So there you go, 48 megabits per second down, 13 up, 39 millisecond latency. Sometimes even going down the street, it's up in the 200s. It really just depends on your surroundings. It's still pretty neat that with this dish and with just a simple DeWalt battery that most people have laying around, you can essentially have high-speed internet anywhere you go. And again, once you're connected to it like this, it automatically will connect to your dish, and you can see on my Wi-Fi page, go to your Wi-Fi section, and it is automatically connected just like it's another router in your house. Well, there you go. So it works. Really thanks again to Dig. I wish I knew his actual name, but credit to him where credit's due. This is a really, really cool project to be able to do completely on your own with a 3D printer and the parts listed for relatively low cost, and have super portable high-speed internet wherever you want to go. So anyway, I hope this video was informative for you. I hope you enjoyed it. Let me know if you have any questions, if you want me to try it, in some other way. Starlink in no way paid for this video. They're not a sponsor or anything like that. I just bought it because I thought it was really neat, and I've been happy with it so far. I just use it really as a kind of a backup emergency source of internet if needed, or if I'm on the go and don't have a cell signal or whatever. It's just kind of nice to have as a backup. If you're interested in Starlink though, I do have, since I am a customer, I've got a link that I can share that will give you a little bit off of your subscription. Anyway, hope you enjoyed the video. See you in the next one.